All right, let's see how you did on your box plot problems with outliers and the application problems where you were comparing box plots. Okay, here we go. So this first one, let's see, I walked through all of the coming up with a fence at negative 39 and 52. So if you take a look at this data, I want to see, is there anything below the negative 39? No, there's not. Is there anything above the upper fence of 52? And yes, there is. 55 was above the upper fence, so there is your upper outlier. Here, comparing these two box plots. Let's see. 50% of the males weigh between 160 and 190. So that's 160 and 190 right here. No, that's not correct. And so then this second one was true, that 25% weigh more than 130. The median of the males is at about 162. So that was true. Next, we've got the male students have less variability. That's false because look at how much more spread out the male data is than the female's data. So much more variability amongst the males than the females. Okay. The top 50% of males are heavier than all of the females. Okay. This is an important comparison that this top 50%, see from the median up, is more than all of the females. So that's true. That's true. And then that middle 50% of the females is not more varied. See, this is a much smaller variability than what was happening with our males. Okay, next. Let's see how we do. Okay, so here I had asked you to, you had you had to make a decision and then support your decision. So first we had to actually do the graphing and the looking at the data. Okay. So this was about that additive that we were putting in there and seeing if it helps the cars get better gas mileage. So here we go. So here are the summary statistics for additive A. See, they give you the min. You get the 5-number summary, the min, Q1, median, Q3, and then the data pieces that are above the Q3. Okay. So anyway, so I walked you through getting the information and the fences for box plot A. So the upper fence was at 13.5. The lower fence was at negative 3.5. I don't think you're going to get negative, um, negative gas mileage. What's that? Is that difference? Um, Gotcha. Difference traveled record. The difference in the distance that they did with the additive minus the distance without the additive. Okay. So then you could get a negative. All right. So if this lower fence is at negative 3.5, what are lower outliers? Anything below the lower fence. So look here. 2 values are below the lower fence. Okay. My upper fence is at 13.5, but I can see there is nothing above the upper fence. You have to be below the lower or above the upper. And there was nothing there. So all we had, so here is my graph of box plot A. Now, FYI, I did come down, I had the chart down here. I had the scale already on here for you. Okay, so there is where our 2 lower outliers are. Then fence or our whisker goes to the next piece of data inside the fence. And then there's the approximation of where those box was and so on and so forth. All right, look at this box plot B. It ended up having a huge IQR of 27. This IQR on the additive A, only 3. This IQR on additive B, 27. Holy moly. Way more varied. Anyway, once I got those fences, there was nothing above the upper fence, nor was there anything below the lower fence. No outliers. Okay? And that was because this was so incredibly varied. Look at how much more um, cohesive or consistent. That's the word. Look at how much more consistent this additive A is because the data is more closely clustered together than that additive B. All right, so now after you have gotten these graphed, now you're going to make some decisions about what this data means to you, okay? That's what this class is doing. We're not just going to be doing the graphs. That was the easy part. Now we got to draw conclusions and do application of those things. So here we go. The next question then is this. It says, one of the ways that they're going to consider the effectiveness is if the proportion of cars that have increased gas mileage. So they want to see which one had a better proportion of cars, higher percent of cars that have an increased gas mileage when the additive is in those cars. Okay. So that means I'm going to decide based on percentages of vehicles, and I can tell that from my box plot. The second choice is going to be about the average, the mean. So that's interesting because our box plot just gives us median, the middle, which is not the same thing as the mean. Okay, so we're going to discuss that in a minute. But let's take a look. So the first question, additive A or additive B, which would you recommend if the goal is to increase the gas mileage in the highest proportion of cars? Explain your choice. Well, let's go look at our picture. We want highest proportion of cars and the highest gas mileage. Well, you could actually choose either answer depending on if you supported it correctly. Okay, so what we're going to do here is we're going to talk about this top percentage. Do this in terms of percentages. So I could say that this whole entire top 25%, entire top 25% is above all of that there. Okay, I could also say, look, I can match this up. I could say the 75% of additive A is above the bottom 50% of additive B. So I'm comparing percentages to support my answer. Okay, that's the key to getting this correct. Comparing percentages to support your decision. All right, so that means whenever I came over here, so like I said, you can choose either, but it's how you explain your choice. So what I did here, you chose additive A, say something like the top 75% of additive A is better than the bottom 50% of additive B. If you chose additive B, you can say the top 25% is better than all of additive A. Okay. The key, supporting it with percents of data. All right. Now, part 2 says, what happens if you want to support with the highest mean? So this is really kind of beyond what we've talked about yet, but that's okay. We can have this little discussion because I think you can see it here. Your mean is not represented with the median, okay, or your Q1s or your Q3s yet. We will eventually get to talking about that relationship between mean and median and how you know if they're similar or one's greater than the other, okay? That's going to come later in this unit. So we haven't discussed that, but I think you could be able to tell by this data. Can you not just see that Boxplot B has so much more data above and higher than what's happening with Boxplot A? So these upper ones are going to pull that average up. If you make really good grades, it's going to pull the average up. So I know that my average is going to be pulled up in this upper direction because there's these datas so far up here. Okay, so that's the way that you would support that is that, because there's some cars with additive B that have way higher average gas mileage, then this pulls that average gas mileage much higher. Okay, it's a much higher difference between those additives. All right, so I think that is the conclusion to our stuff, and then tomorrow you're just going to be having a summary assignment for that. All right, good luck to you.